Module 1, Lesson 22, Getting the Job Done, Speed, Work, and Measurement Units. And we are looking primarily at speed in this lesson. Pretty much working with the formula distance is equal to rate multiplied by the time. So learning target, we are definitely working on unit rates in here. And of course, if we're doing unit rate, we have ratios and we have equivalent ratios. All right, I can statement. I can take a given speed situation and represent the quantities involved with the formula for distance. So the distance is equal to the rate multiplied by the time. And we will frequently see this expressed as d equals r times t. So distance, how far something travels. Rate is the measurement of speed, and we have that happening over time. So we'll take a look at that. All right, classwork. So if an object is moving at a constant rate of speed for a certain amount of time, it is possible to find how far the object went by multiplying the rate and the time. So in mathematical language, we say that the distance is equal to the rate multiplied by time. So for example, maybe I have a distance of 100 yards. I am going to represent the speed as a rate, and maybe I'm going to represent it as the rate of feet traveled in a second, and then I have an amount of time that is involved, and maybe that is seconds. And this should look really familiar because right now you should be seeing that we have these positioned diagonally from each other, which means they will cancel each other out, and we will be left with a measurement unit of distance. And we'll look more specifically at what that looks like, but I wanted to connect that to what we've worked on some prior lessons. All right, so in class we'll actually have a walker and we'll have a runner, and we'll have them walk 50 feet, we'll have them run 50 feet, and we will use the information that we collect from their experience to do a little bit of calculation here, calculating the rate of speed. So we are going to, in class, have them walk 50 feet. And we are going to keep track of how long that takes. So, for example, maybe it takes them 10 seconds to walk 50 feet. And then we are going to be looking for this missing information, this rate here. And there is a hint down here. It says consider the units, the rate unit that you want to end up with. And if you want to end up with the rate for feet per second, then you divide the distance, feet, by the seconds. So for example, if for my rate here I want to have feet per seconds, I need to take the feet and I need to divide it by the seconds. So I take the 50 feet and I divide it by the 10 seconds, and I find out that I have 5 feet per second. And that is the speed at which the walker is traveling, 5 feet every second. So looking at that again, let's have a distance here of 75 feet. And we are going to pretend that it takes them 25 seconds to walk that distance. If I want to end up with a rate unit of feet per second, so if I want to measure their speed by how many feet they travel in a second, then I need to look at the information I have and I need to structure my problem so that I have feet per second. Feet per second, and I know I have 75 feet per 25 seconds, and 75 divided by 25 gives me 3 feet per second. Now it's possible, and it might feel a little bit weird, but it is possible to set it up this way. maybe you're traveling 100 feet and it takes 13 seconds, it's possible that I could have seconds per feet. So in other words, figuring out how long it takes to travel a foot. So I could want a unit of seconds per feet, in which case I would take 13 and I would divide it by 100 because I want seconds per feet. And I can see that they are traveling 13 hundredths of a foot per second. And that sounds a little bit awkward, and we don't typically express speed this way. When we use units to talk about speed, to talk about this rate right here, we will usually have our distance divided by our time. That's how we measure speed. But I wanted to point out that with the information here, we can do some interesting things. Sometimes it is useful to know how many seconds it takes to travel a given distance. All right, so we have the runner, and so it would be 50 feet. And we will pretend that it took the runner 8 seconds. And I would like to know the number of feet they traveled each second, so I want to know feet per second. So I'm going to set this up as feet per seconds, and the feet is 50, and the seconds is 8. And I've got a little division problem here. 6 times 8 is 48. And I know that 2/8 is equal to 1/4. So I could say that they are traveling 6 1/4 feet per second, and maybe you turn that into a decimal, 6 25 hundredths feet per second. So every second, that is how far they are traveling. All right, so Chris Johnson ran the 40-yard dash in 4 24 hundredths seconds, and the question is, what is the rate of speed? What is this rate right here? And it says to round the answer to the nearest hundredth. Well, I know that the distance traveled was 40 yards, and I know that the time was 4 24 hundredths seconds, and I know that I would like to know the yards per second. Remember, I talked about usually when we are talking about speeds and rate of speed, we are having the ratio of the distance to the time. So I need yards per seconds, and the yards is 40, and the seconds are 4 24 hundredths. So I need to take 40, and I need to divide it by 4 24 hundredths, and I need to round it to the nearest hundredth. And in class, I'll have calculators out for this. And I get a lovely decimal looking something like this. And it keeps going. But I went to the thousands place because to round to the nearest hundredth, which is here, I have to look at what's in the thousands place. And so I'm going to say that we have a rate of 9 43 hundredths yards per second, which is pretty fast. I'm pretty sure that that's moving pretty fast. So once again, we have our formula here, a given piece of information. We substitute in the distance, we substitute in the time, and then we ask ourselves, what do we want the rate unit to be? Well, I wanted yards per seconds. So I set up my problem to match yards per second. All right, so in lesson 21, we converted units of measure using unit rates. If the runner were able to run at a constant rate, how many yards would he run in an hour? And this problem can be solved by breaking it down into 2 steps. So work with a partner, make a record of your calculations. How many yards? And so the first question is, how far would he run in 1 minute? So this would be step 1. So we're going to scale up from a second to a minute, and then from a minute to a yard. And we have already figured out that the runner is running 9 43/100 yards per second. Now I want to scale that up to 1 minute. And I know that there are 60 seconds in 1 minute. So now my seconds are going to cancel out, and I am going to be left with yards per minute. I guess I'll abbreviate minute there. So 9 43/100 times 60. Which is 565 8/10 yards per minute. So remembering back to lesson 21, when we were canceling out diagonally, notice that I have used now the rate of seconds to minutes to help me change this yards per second to yards per minute. Powerful stuff there. And now that I have minutes, I need to scale up to hours. And I know that there are 60 minutes in 1 hour. So notice that I've again used what we did in lesson 21, and I have set it up so that the minutes will divide each other out, and I will be left with yards per hour. And of course, I've got to take the 565 8/10 and multiply it times 60. And I'm going to get 33,948 yards per hour. And if I were feeling really feisty, I could say, how many miles per hour is that? And to do that, I would have to get rid of yards, so I would have 1 mile, and I would have 1,760 yards, so that the yards will cancel, and I will be left with miles per hour. And I would have 33,948, and I would divide it by 1,760. And find out that I'm about 19 29/100 miles per hour, which is a really good rate. All right, so I'm going to step back and walk through this in a slightly different manner. Still going to try and get the same information, but I'm going to try and show you a little bit more advanced way of doing it, or maybe try and show you how to, instead of 2 steps, you can maybe do it more in 1 step. So we know that we have 9 43/100 yards per second, and I want to turn that into minutes. And I know that there are 60 seconds in 1 minute. So now my seconds are going to cancel out. And then I would like to find out yards per hour. And I know there are 60 minutes in 1 hour. So the minutes are going to cancel out. So now I've got 9 43/100 times 60, and then times 60 more, and I would have a yards per hour. But I would like to end up, and for this case I'm extending it a little bit, miles per hour, and I would have 1 mile and 1,760 yards. So my yards will cancel out. The only units that I have left now are miles and hours. So I would have 9 43/100 times 60 times 60 divided by 1,760, and my units are miles and hours. So I know that that can look overwhelming, but it consolidates it into one problem. Instead of doing a step, stopping, multiplying everything, I can set it all up to get my result. And on this next slide, it kind of walks us through. We had it as 2 steps, but we could actually consolidate it down. We know that we've got 9 and 4,300 yards per second, and we know that there are 60 seconds per minute and 60 minutes per hour. And just like I was showing, these things are going to divide each other away, and we are left with yards per hour. And then I have to do the 9 and 4,300ths times 60 times 60. And of course, I extended by actually turning it into miles per hour. And this says here, cross out any units that are in both the numerator and denominator. So find the things that will cancel each other, that will divide each other out to make 1. So how many miles did the runner travel in that hour? Round your response to the nearest tenth. Well, I already showed this to you. We actually turned this into a miles per hour problem already. We found the yards were 33,948 yards per hour. And I want to turn that into miles per hour, so I need miles per hour. So I need the yards to cancel out, so I need 1 mile, and I want the yards to cancel, so they'll go diagonally, and I've got 1,760 yards. So I wind up dividing 33,948 by 1,760 and getting 19 and 2900ths miles per hour. And it says to round to the nearest tenth, so I really should say I've got 19 and 3/10 miles per hour. Now, it's really important. I know that there's a lot of numbers flying around here, a lot of labels and stuff, but this is an accumulation of stuff that we have been working on. So hopefully you're feeling comfortable saying, hey, I see some rates here. Hey, I remember that some things are going to divide out, so that it will make a little bit of sense. All right, so exercise 1, road trip. I drove my car on cruise control at 65 miles per hour for 3 hours without stopping. How far did I go? And right here we have the equation. The distance is equal to the rate multiplied by the time. So right here we have a rate, 65 miles per hour, and we have a time, 3 hours. And the question is, how far did we travel? Let's see, I've got 65 miles and hours, and I'm multiplying that by 3 hours. So the hours are going to cancel each other. I'm checking my units, making sure that everything works right, and I am left with just a unit of miles, and 65 times 3 is 180, and 15 more for 195. 195 miles. Notice that this problem was different than the other ones that we had looked at. In this one, they did not give us the distance. What they gave us was the rate, so we had to substitute that in. They gave us the time, so we had to substitute that in, and we used that information to then find the distance. On some of the other examples we had looked at, they were giving us the distance, they were giving us the time, and we were finding the rate. So it's important to recognize with this equation that we can solve for each of the things. We can find the distance, we can find the rate, we could also find the time. Okay, so on the road trip, the speed limit changed to 50 miles per hour in a construction zone. Traffic moved along at a constant rate, 50 miles per hour, and it took 15 minutes. So I'm noticing here that I have my rate, and I have a time. What was the distance of the construction zone? So in other words, what was the measurement length of the construction zone? So I'm going to do a little substitution here. I see I've got my rate of 50 miles per hour. I see that I've got 15 minutes, and it was very nice of them. They gave that to me as an hour, 25 hundredths of an hour, or 1/4 of an hour. And it says that we are going to round the response to the nearest hundredth of a mile. I'm going to check my units. This will cancel this. And I kind of like to rewrite these so that it becomes more clear. I've got 50 miles per hour, and I'm multiplying that by 25 hundredths hours. And it might even be more clear if you're putting that over a 1. So we see that this hours is in the numerator and this hour is in the denominator, so that they will divide each other out. And I'm left with the unit of miles, which is good because I'm supposed to be finding a distance. And so then I need to take the 50 and multiply it by 25 hundredths and find that I have 12 and a half miles. 12 and 5/10 miles. So the construction zone is 12 and a half miles long. And I calculated that because I had a rate. I knew how fast I was traveling. I had a time that I was traveling. I traveled at 50 miles per hour for 15 minutes, and I was able to figure out that the distance covered is 12 and a half miles. All right, so the relationship between distance, rate, and time. And state the relationship as many ways as you possibly can. So we're trying to really understand what's going on here. And so I know that distance is equal to the rate multiplied by the time. That's the one that they gave us. But then I also know that the rate is equal to the distance divided by the time, miles per hour, or feet per seconds. So there's two relationships that we have looked at a lot in this particular lesson. It is also possible to say that the time is equal to the distance divided by the rate. That is not something that we have played with. So don't stress out about that, but I want to point out that the relationship is there. For this lesson, these are the two big relationships that we want to focus on. And they can be summarized this way. We can find the distance if we know the rate and time. So I can find the distance if I know the rate and the time. And I can find the rate if I know the distance and the time. So depending upon the information they give us, I should be able to figure out the distance and the rate. So distance, rate, and time are related in this basic formula here. Distance is equal to the rate multiplied by the time. If I know any two of the values, if I know the distance and the rate, I can find out the time. If I know the time and the rate, I can find the distance. If I know the distance and the time, I can find the rate. So if I know two of the values, I can find the third, which is very similar to our fact families in multiplication. 2 times 3 connects with a fact family of 6. If I know any two of the values, I can figure out the third value. So trying to build a little connection there with what we know about multiplication. So hopefully, now that we have reached the end of the lesson, you are feeling pretty comfortable with you can be given a speed situation and represent the quantities involved with the formula for distance. If you can use this right here, distance equals rate times the time, to find distance and to find rate. We have not focused very much on finding the time. Not that it should be very hard, because the time is equal to the distance divided by the rate. So it shouldn't be too intimidating. If I know the distance is 50 miles, and I know that I'm traveling 5 miles per hour, so 50 miles, and I've got 5 miles per hour, then I would know that it would take me 10 hours. Miles will cancel out here, and I'll be left with 10 hours. All right, so identifying and describing the fixed relationship between two values. Well, that is the rate stuff that we were working on. As we were working on rates, looking at ratios and equivalent ratios. So this is actually kind of a fun lesson. And this concludes Module 1, Lesson 22. If you've got questions, make sure you talk to your teacher and make sure you complete your problem set.